Welcome to CE 405 Environmental Engineering 1 Module 4 Part 1. In the previous module, that is in the third module, we discussed about the water treatment systems up to sedimentation cum coagulation tanks. In this module, we are going to discuss about the filtration process, the process which comes immediately after the sedimentation cum coagulation process. Why this filtration is needed in the water treatment system. In the previous treatment, that is in the sedimentation or sedimentation cum coagulation treatment, the flocks are formed. That is in the flocculation chamber. By adding coagulants, the flocks are formed. In the settling tank, these flocks are assumed to be settled down, and this is removed through the drainage system. But the 100% removal or settling of these flocks are not happening in the sedimentation tanks. So we have to provide a filtration system for better clarifying or better impurities removal from the water effluent that is coming from the sedimentation cum coagulation or from the plain sedimentation tanks. So what is a filtration? It is the removal of impurities from the effluent water coming from sedimentation tanks or sedimentation cum coagulation tanks. The water is passed through a granular media or a filtration media which consists of a sand layer and a supporting layer which is made up of gravel. Then the filtration will remove color, turbidity, odor, and pathogenic bacteria from the effluent water. Then what are the mechanisms that helps in filtration of the effluent water? First mechanism is the mechanical straining. What is a mechanical straining? The process that happens while filtering a cup of tea is happening in the mechanical straining process. The particles which has a size greater than the size of the voids cannot pass through these filter media, that is the sand media, and it will trap on the top surface of the finer sand media or the filtering media. This is the mechanical straining process. All the particles greater than the size of the voids are removed through this mechanical straining process. This is the first mechanism happening in the filtration process. Then the second mechanism, that is the sedimentation mechanism. Here, the void space between the sand particles, that is the void space in the filter media, that is the empty space in between the sand particle, will act as sedimentation tanks or sedimentation cum coagulation tanks. The particles entering, the impurities entering into these small sedimentation tanks, small void spaces will settle down in these voids, and it forms a gelatinous surface in the void space. This gelatinous surface will again enhance the removal of impurities from the effluent. It will increase the filtration rate. This is the sedimentation process. That is, each of these voids act as a tiny sedimentation tank. This is the second mechanism happening in the filtration process. Then, the third mechanism. Third mechanism is the biological metabolism. It helps. It happens due to the presence of bacteria present in the water. That is the microorganisms present in the effluent water. When this effluent water passes through the filtering media, the bacteria or the microorganisms will stay in the void spaces of these sand particles. These microorganisms need food. It takes food from the organic impurities present in the effluent water. it converts these organic impurities into harmless substances or harmless chemicals. And these harmless chemicals form a dirty skin, that is a layer of impurities or a layer of harmless substance on the top of the sand filter media. And this dirty skin will support or enhance the filtration process. This is the third mechanism, that is biological metabolism. The fourth process is the electrolytic changes, fourth mechanism. Electrolytic changes means the sand grains present in the filter media and the impurities present in water have the opposite electric charges having opposite nature. By contacting each other, these opposite charges will cancel or neutralize each other. Then the chemical characteristics, then the characteristic of water will be changed due to these opposite charges of sand grains and the impurities present in water. This is the fourth mechanism. These four mechanisms are the basic operational or the functional procedure of the filtration process. The first one is the mechanical straining. Second one is the sedimentation. Third one is the biological metabolism. And fourth one is electrolytic changes. Then, the filter materials used in filtration tanks are the sand, which is the actual filter media, and the gravel, which is used for supporting this sand layer. The sand should be, the qualities of sand should be free from dirt and other impurities. It should be uniform in nature and size. It should be hard and resistant. The effective size of sand, that is D10, should be 0.2 to 0.4 mm for slow sand filter and 0.35 to 0.55 mm for rapid sand filter. The uniformity coefficient CU should be 1.8 to 2.5 for slow sand filter and 1.3 to 1.7 for rapid sand filter. Then the supporting media, that is gravel. It should be hard, durable and free from impurities, used in different sizes, arranged in 3 to 4 layers, each of thickness 10 to 15 centimeters. The coarsest size should be in between 20 to 60 mm, which is placed at the bottom of the filter media, and the finest size, that is 3 to 6 mm, placed at the top of the filter media. This is the supporting system. Then the type of filters. Type of filters, there are three types of filters. First one is slow sand filter. Second one, the rapid sand filter. Third one is the pressure filters. In the next coming slides, we are discussing about the slow sand filter. What is a slow sand filter? As the name suggests, the process is slow. The filtration process is slow. It removes a large percentage of impurities and the rate of filtration is very low. And the quantity of water that passes through this slow sand filter will be very low, so that the water, effluent water coming after the plain sedimentation process is used for filtering in slow sand filter. And the water from coagulation cum sedimentation tank cannot be used in this filter as the flow clog the voids. And the rate of filtration is 100 to 200 liters per hour per meter square. And the bacterial removal efficiency is 98 to 99%. It also removes suspended solids, odor and taste. It can remove turbidity only up to 50 milligram per liter. Then the enclosure tank. This is a basic structure that encloses all the components of a slow sand filter. That is the enclosure tank. This is an open rectangular tank made up of concrete or the masonry, and depth having 2.5 to 3.5 meter, and a plan area of 100 to 2000 meters square. It requires a large area for construction of slow sand filter. Then the filter media, as we have already discussed, sand is the filter media having a thickness of 90 to 110 centimeter and an effective size of 0.2 to 0.4 mm and a uniformity coefficient CU 1.8 to 2.5, and the size of the sand should be uniform. If we are taking the sand with the different sizes, then the finest should be placed at the top and the coarsest should be placed at the bottom of the filter media. Then the base material. Base material is the supporting arrangement, that is the gravel for supporting this sand layer, that is the filter media. The thickness should be 30 to 75 mm, and this should be arranged in layers of 3 to 4 layers having thickness 10 to 15 centimeters or 15 to 20 centimeter or 10 to 15 centimeters. At the bottom layer, the size of the gravel should be 40 to 60 mm, and if we are providing an intermediate level, then we have to accept a gravel size of 20 to 40 mm. If 2 layers are arranged, then the size of the gravel at the bottom layer should be 20 to 60 mm. And then the top layer, the gravel having size 3 to 6 mm is used. This is the base material or the supporting material for the sand media. Then the next arrangement is inlet and outlet arrangement. Inlet chamber with the automatic valve admit the effluent. This is the inlet arrangement that we are going to discuss in the coming slides. And outlet is the filtered water well. And the filtered water well at the outlet side with a telescopic tube to maintain the constant discharge. These two components will be discussed in the coming slides. This is the schematic representation of a slow sand filter. Here you can see the inlet chamber, the filtration, the middle portion is the filtration chamber and portion is the outlet chamber. This is the basic structure of a slow sand filter. Here you can see the filter media, that is the sand layer you can see there, that is marked as 90 centimeter. Below that, the supporting media, that is the gravel, is provided. And below the gravel, there is a collection mechanism, that is the filtered water collection mechanism is placed below the gravel. That is the drain pipes are provided. These drain pipes are the narrow pipes with the holes on the top surface of the pipes. This will collect the filtered water and the water will flow into the main drainage, and this main drainage will connect it to the filtered water well. This is the structure, and the total structure is constructed over the RCC, that is represented below, and the inlet valve is provided and the outlet valve is provided. And next is the working of the slow sand filter. First, the effluent coming from the plain sedimentation tank will enter into the inlet chamber through the inlet valve, which is an automatic valve. Why this automatic valve is provided? Because we have to arrange or control the flow of effluent water into the filter media. There should be a uniform rate of water entering into the filter media, and the filtration rate should be in a uniform rate. So we are providing this automatic valve. A particular level of water should be maintained in the inlet chamber, and from this inlet chamber, water is entering into the filtration chamber through the opening provided in the inlet chamber. And this opening is provided throughout the width of the filtration tank, so that a uniform rate of water is entered into the filtration chamber. And this entering of effluent from inlet chamber to the filtration chamber should not disturb the filter media present in the filtration chamber. So the water is coming from the plain sedimentation tank, entered into the inlet chamber, then again it entered into the filtration chamber. Then the water passes through this filter media, that is the sand media. Filtration happens, and the water will pass through this supporting media, that is gravel, and collected through the drain pipes, and which is connected to the main drainage, that is the main central drain marked below the figure, that is main central drain. This main central drain is connected to the filtered water well, and from the filtered water well, the water is taken out to supply reservoir for storage. And a telescopic tube is provided, an adjustable telescopic tube is provided at the outlet pipe in the filtered water well, in order to adjust the head a constant. That is, the head should be in a constant level in the filtered water level, and the water withdrawal should be in a uniform rate. And here you can see head loss or filter head, that is HL, marked in the outlet, that is the filtered water well. And this HL is the difference between the water level in the filtration chamber and the water level in the filtered water well. This is HL. Usually, if the filter media is working in a good condition, then this head loss should be in between 10 to 15 centimeter. By clogging the sand layer, that is the filter media, this head loss will be increased. If the head loss is increased up to 0.7 to 1.2 meter, then we have to replace the sand layer or clean the filter chamber, that is the filter media. This is the working of a slow sand filter. Next stage is the cleaning process. As I already told, that is, if the head loss in the filtered water well is in between 0.7 to 1.2 meter, we have to clean the filter media. This cleaning is done in such a way that the top layer of the sand media is scraped out by using labor, and all the operations in the filtration tank will be stopped at that time, and all the top layer will be removed, and it is then washed and replaced in the filtration chamber. This will take a minimum of 24 hours, and large number of labor is required for this process. And immediately after replacing this sand layer or filter media, we cannot restart this filtration tank, because there is no dirty skin or the filtration enhancing agents will not be present in this sand layer. That is the bacteria, the sedimentation mechanism, and pyrolytic mechanism will not happen in this stage. That is, the purely cleaned filter media will not support these mechanisms. So we have to wait for another some duration for creating all these mechanisms to take place in the filter media. So we have to wait for 36 hours to replace or restart this filtration tank back to the working condition. So because of this reason, we have to provide a standby filtration tank for continuous operation of the water treatment system. This is the normal working and cleaning of slow sand filter. All the steps are given in the slide. Then next is the uses of slow sand filter. Slow sand filter is used for small plant that I have already told. That is the water, effluent water coming from plain sedimentation tank is passing through this slow sand filter. It is used for water with low color and low turbidity because the turbidity removal in slow sand filter is very low. That is 50 milligram per liter. It requires huge area. That is, the plan area of a slow sand filter is 100 to 2000 meters square. And a huge quantity of filtering materials. If the plan area is huge, then the material required for the filter media will be very large, and it requires a huge space. That is, for the continuous operation of a water treatment system, we have to provide a standby filter tank also. So it requires a huge space for constructing this filtration tank. This is the major disadvantage of slow sand filter. This is the working, cleaning and uses of slow sand filter. Next is a design problem of slow sand filter. That is, design 6 slow sand filter beds for the following data. Assume 1 unit out of 6 as standby. Population is 50,000. Per capita demand is 150 liters per head per day. Rate of filtration is 180 liters per hour per meter square. And length of each bed is twice the width. The solution or design of this problem will be discussed in the coming session. I hope you all understood the filtration process, the mechanism of filtration, the types of filter, and the slow sand filter and its working, cleaning and uses. By this, I am stopping this session. Take care. Thank you. Bye-bye.